Let's look at something called an if statement. An if statement in JavaScript is a programming flow controller that allows our code to go either in one direction or another direction. So right now the code that we've written is just going straight down. It's going this line, then this line, then this line, then this line, and it's just going down here. But as soon as we hit an if statement, we can get our code to do different things. So an if statement looks like this. We type the word if, we do some brackets, and then some curly braces like that. So in here, this is what will happen if the if statement is true. After this curly brace, we'll type else like this, and this is what will happen if the if statement is false. So this is if the logic is true, what I like to call the true path, and this is if the logic is false, aka the false path. Now, I'm saying logic here because right now, our code doesn't know which path to take. It doesn't know to take the true path or to take the false path. And that's what these brackets right here are for. So let's say in here, let's go alert, true path was taken. And let's do an alert in here, false path was taken. So the code needs to know which path to take. So inside these brackets here, if whatever is in here equals out to be true, like that, then the true path will be taken. So I'll go refresh, and you can see it says the true path was taken, because what is between the brackets is true. If what's between the brackets is false, then the false path will be taken, like that. The false path was taken. So in here we have a chunk of logic to help determine which path to take. So as an example, I could write is human in here, and we know that the variable is human has a Boolean of true inside it. So the path that will be taken is the true path, because that is true. Or I could change this to is dinosaur, and now we would take the false path, because whatever is inside of this variable is false. Now, some other things that are false are like something like a 0, that will be false. But if I change this to a 1, that would be true. And an empty string like that, that is false. But if there's something in it like that, then I get true. Now, because this string has some stuff inside it, we can actually reverse out the option. So we know that this is going to be true, but if I put an exclamation inside it, an exclamation or in front of it, that means not. So that means if this is not true. So if I go and refresh, you'll notice that I get the false path now because I'm checking to see if it's not true. So something, a simple example would be like this. If it's not true, then it will go on the false path. So this is changing it to be opposite. So as an example here, if is human, if I type is not is human, and I would refresh, and I would get false, because what is inside here is actually a true value. So I'm checking to see if what is inside here is a false value. So if I change this to false with the exclamation, you'll notice that I'll get the true path now. And what's happening is this says compare the opposite, essentially. So by default, our if statement is looking for a true value in here. But if we put an exclamation, now the if statement is looking for a false value in here. So combining these together, this is false in here, and this is looking for a false. So if together, that is actually true. So this says, if this is not true, which it is not true, so that means that overall it is true. I know this is super confusing, but the exclamation basically reverses out and then checks for false instead of checking for true. That's really what the exclamation does. So let's take this example here. I'm going to put my human back to true. Now let's say I want to check and see if it is a human and it's not a dinosaur. The exclamation is not. So I can have logic that combines together with if and or statements, or and or statements. So I want to see if it's a human and it's not a dinosaur. So in JavaScript, to write and, you do 2 ampersands. So that means and then I can type not is dinosaur. So that says check to see if it's a human and also check to see if it's not a dinosaur. So what path this is going to take now is determined on what these two values are here. So it's going to check this is human. Now it's always checking for true. So is human is true. And then this means check to make sure that the dinosaur is false. So yes, dinosaur is false. So this is true and dinosaur is false. So those things together are both true because that's the logic. So I will get to go down the true path because this is true and the combination of this is also true. So that is what the and does. So let's do another example. We could do if is human or is dinosaur. Then we'll just write alert creature. Now this is checking to see if human is true or is dinosaur is true. And whichever one is true, that's okay. We'll go into the true path. So let's just make sure we put an else here. Alert, not a cool creature. Okay, so if the human is true or the dinosaur is true, then we're going to go in this path. But if either of them or both of them are false, then we'll go in this path. So I'll refresh. That's the true path. So we got creature here. But let's say both of them are false. So this one is not true and this one is not true. So we're going to go down this path now, which is not a cool creature. But let's say what if both of them are true, like this. So now is human is true and is dinosaur is true. So we'll go refresh and we get creature, which is good because our if statement is checking to see if this is true or if this is true, and they both happen to be true. So our if statement is valid. So when we're looking at our if statements here, we always are checking individual items. So this needs to come out as being true, and this needs to come out as being true. It's looking for truthy values in there, and then this logic statement as a whole needs to be true. So really what the if statement is checking is it's checking to see if this whole logic statement is true. And if this whole logic statement is true, we go in here. But if the whole logic statement is false, we go in here. But that logic statement can be quite complex, like looking at this one here. We're checking multiple values of things. We're checking if something is false, and we're combining them together to see what direction we go. So far, we've only looked at strings and Booleans in our if logic here, but we could actually do numbers also. So we have a couple numbers up here. We have age, and it's 32 right now. So let's go if age is greater than 25, then we'll do our alert in here. So here we have an if statement now comparing some numbers. So if age is greater than 25, if we refresh, you can see we get the true path. Let's say we change this to 45. So if age is greater than 45, we'll go like that and we get, well, it says under 25, but you know what I mean. We get the false path. So we could also do something like less than, like that. So are we less than 45? Yes, we're 32. What about less than or equal? So if we do less than or equal, that says less than or equal to 32. We refresh. So yes, we're less than or equal to 32. We're also less than or equal to 33, etc. We could also do greater than or equal. So are we greater than or equal to 25? Yes, we are, because we're 32. Are we greater than or equal to 32? Absolutely, because we are equal to 32. So we can have logic here based on greater than or less than, or based on true. Now, the similar thing is happening here. Our if statement is checking this whole thing to make sure that all of this logic is true. And we can combine this with all this other stuff. So a really complex example would be if age is greater than or equal to 32 and is human and is not dinosaur, like that, dinosaur, then we can do something. So let me just comment these two out. So we've got a big chunk of logic here. Let's see what happens. Do we get the alert woot? We do. So this says if the age is greater than or equal to 32, which it is, it's exactly 32. So that little chunk is true. And then it uses and, which checks to see if this chunk is true. Is human? Well, yes, human is true right here. And then it uses and again and checks to see if this little chunk of true is true. So is dinosaur not true, which is what the exclamation, yes. So all these together are true, and we're coming into the true path. And we can do even more crazy things. Like, as an example, we could put brackets in here like this. So this now says, let's change this to or. So this says, check to see if the age is greater than 32, and also check to make sure it's a human or a dinosaur. So we'll still get a true here like this. We'll still get the if statement. But if we change human up here to be false, so now we're neither human nor dinosaur. So I'll refresh, and you can see we don't get an alert because I just don't have the else statement. So this piece of logic here is pretty complex. It's checking to make sure that the age is greater than 32, and it's checking to make sure this group ends up being true. So this group is checking if human is true, or is dinosaur is true. So neither of them are true. So this chunk of logic is coming out false. So the ampersand is checking everything after the ampersand to see if it's true, but it's false. So since this is true and this is false, then the whole piece of logic is false and our alert does not happen.
The final type of comparison that we can have in our if statement is an equals comparison. So we could do something like check to see what is inside a variable and if it's equal to a piece of text. So let's have another variable up here. I'll call it name equals Thomas, like that. And now I can compare what's inside that. So I could go if name equals Thomas, then I can follow the true path. Let's do an alert. So here's my example. I'm checking the variable and I'm comparing it to the string Thomas to see if they are the same. So if I open this up in my browser, I get this. The names are the same. Now, you'll notice here that I'm using two equals, and that's different from one equals. One equals up here means set, so I'm taking the value of Thomas and I'm putting it into name. But here I'm using two equals, and that means compare the two values. So I'm comparing what's inside this variable with this string. Now it's extremely strict here. This actually has to be capitalized exactly the same way. So if I put a lowercase t and refresh, you can see it says the names are different. So it's super, super strict because it has to be spelled exactly the same way as this. So using this sort of system here, we could actually prompt for a name and then compare and do something from it. So let's change this variable here, call it new name. And then up on the line previously, I'll go var new name equals prompt, and we'll get someone's name and do a comparison. What is your name? So this is going to pop up a little dialog and ask them what their name is. It's going to put it into this variable, and then we'll use a comparison here. So now what I can do is if I refresh, it'll pop up and ask me for my name. And if I type Thomas like this with a lowercase t and hit enter, you'll see it says the names are different because I spelled it differently. But if I type it with a capital T and hit enter, you can see it says the names are the same. So right here, we're doing a comparison. We're comparing between the content of this variable and this string itself. And this can be added on to everything else that we've looked at with if statements already. You can do or with it, you can do greater than, less than, you can do Boolean operations, you can do everything. So all this if statement stuff, all these comparisons all work together to form a complete sort of binary logic system